So in this problem here, we know the school canteen sells coffee cups and they claim it is 250 milliliters. It's known the amount of coffee cups is normally distributed with a standard deviation of 6. So this is the population's standard deviation. It's not an estimate, it's actually true fact. So I know that coffee cups are actually indeed normal with a 250 and a 6 milliliter standard deviation. And I want to find out if Adam wants to know if they're containing less coffee. So the alternative is that the mu is actually equal to 250, whereas the alternative is the mu is less than 250. I want to find out, I know that they have alphas 0.05, and N, Adam measures 10 cups of coffee, and he finds X bar, so N is 10, and his average X bar is equal to 248. And so that's enough information for me to find out if they're selling less than 250 milliliters of coffee. I'm going to do it two ways. The first method I'm going to do is this is clearly a one sample a z-test, because I know the standard deviation is 6. So if I go stat, test, z-test, I have my statistics, it's 250, 6, 248, 10. I don't put divided by root 10 because I'm putting n in here and the calculator will divide automatically for me. I've chosen the less than criteria and I'm going to calculate it, and I can see that the p-value is equal to 0.146. So therefore, we reject. No, we don't. We fail to reject. We fail to reject H0. Getting a sample this big out of an average of this or groups of 10 is not that uncommon, is what we're saying. So this could be a true statement. And so we fail to reject as the p-value is bigger than alpha, and Adam's claim is not supported. They are not selling less than 250, or there's not enough evidence to claim that that's true. So that's the one way I could do it with the z-test. The other way we could do it is with normal CDF. And if we consider this, here's my normal curve, and here is 250, and down here is 248. Constructing this normal curve, though, if I would make this is made up of groups of 10. Each data point here is an average of 10 coffee cups. And if we got a lot of them, eventually we would get this normal curve. And we want to know, is it possible that a group of 10 coffee cups would be less than 248? What's the probability of that happening? This is my p-value. So if I go to my normal distribution, and if I go normal CDF, I'm going to go from a big negative number, and I'm going to go up to 248. My mean is 250. But my standard deviation here, I have to divide it by the square root of 10, because this normal curve has a standard deviation of groups of 10. This has to be considered. That's the central limit theorem. And when I do that, I again see I get this p-value here. And so there's two ways to do it. The easiest way for sure is with your z-test. Now B, it says, Adam, let me pull this down here. So it says, Adam decides to collect a larger sample. So we don't know what n is. Find the average to be 248 again, but this time there is sufficient evidence to conclude that 1% is less than the average amount. So if I picture this, so now I have this normal curve, and here is 250, and here is 248, and now we're saying that this probability is 0.1 or smaller. Right? We do not know what n is. So if I want to find this probability, I want to find n, well, I have to actually going to go to my z-score value. And z-score is going to be x bar minus mu over the standard deviation divided by the square root of n. Okay, I'm going to have to use this, so I'm going to convert my area to a z value, and then for my z, I have all of the, I'll have z, I'll have x bar, I have mu, I have s, I can calculate n. And so to do it, I'm going to go second inverse normal. My area is going to be 0.01. My mean is 0. My standard deviation is 1. And that gives me negative 2.3263. So now once I have that, I set this value equal to, so negative 2.326 is equal to 248 minus 250 over 6 over the square root of n. And I have equal to because I'll figure out the less than or greater than. I do that at the end for myself. So I know if I do that, I'm going to multiply both sides by 6 over root n, 6 over root n, 6 over root n, and I get negative 2 equals, so negative, so if I take this value times 6, I get negative 13.958 over root n. And so I can do that. I know then n square rooted is equal to 13.958 over negative 2. And so n will be, if I do this calculation, if I divide this value by negative 2 and I square it, I get 48.7. And I want it to be at least this value or smaller. In order to do that, I'm going to make n larger, so I'm going to say n is equal to 49. Even if this was 48.1, I would round to 49 because I want to make sure I have the correct probability. And that is how we find the minimum number